All right, Marcus. This is your 65 Deluxe Amp non-reverb. And first thing we're going to do is the AC power section here. Like I was saying, this ground's too short, so if this gets a yank, ground comes off. There's no safety ground. Chassis could go live if one of these gets pulled off and touches chassis. It's also backwards on the receptacle here, hot and neutral reversed. And then we're gonna skip the switch to free it up for negative feedback switch. So we're gonna take hot directly to the fuse and take and then from the fuse to the switch, and the switch to the power transformer. And then on the neutral, which will be here, we'll just go straight to the power transformer. I'm looking at your swapped out power switch and standby switch, and I can see now why they're upside down, because there just probably isn't room on the chassis here for this exact switch that they use as a replacement. The contacts would be touching the chassis, so I think you're just gonna have to live with it being upside down. You're probably used to that by now, but it definitely always freaks me out. Okay, let's get busy. Okay, so we took off the strain relief, fed a little more through, exposed some more hot and neutral wire so they could be shorter than this ground, which is now long and still soldered to the chassis. And now we'll clean up the power courtesy outlet, wire it the right way. These are now just scraps of your old IEC cable. This is wiring that goes to the switch, which we're going to decommission so that we can use it as a negative feedback switch, but I will keep this wire. Same with this one. A little bit of fresh solder to get it going. Enough. Again, this was wiring in the old ground, the old polarity switch for the AC, which we are decommissioning, but we'll keep those wires for you. This one's just a scrap of your IEC. Okay, I'm gonna just finish removing all of the switch wiring here to make room for negative feedback switching. This may reach. Oh, that's beautiful. Okay, good. And then this end of the switch. Kind of watch these heater wires here. that. This is to the switch, so we will keep that. That will come from the fuse. And the old transformer primary that's wired to the fuse will no longer be wired to the fuse. Well, that was just tack soldered on there anyways. Not so cool. So we'll keep these twisted here for minimal noise. And then we'll feed this transformer primary back to the courtesy outlet. Take it in behind the grid wire and everything for this 66. So it's out of the way physically and electrically. That's pretty good. Clean that up a little. You know, it's long enough that I'm just gonna trim it and re-strip it. Should be 18. Just tin the very end of that, just to keep the strands together but not make it rigid. All right. Beautiful. Nice mechanical secure connection there. And this is our new neutral. And again, this is feeding the wide slot of the courtesy outlet, which is neutral. Before it was wired backwards. So we were given hot to the neutral side of the courtesy outlet. You gonna make room? Quite like that. Let's go again. Maybe. Still don't quite like it. I'm gonna feed this one first because it's a little less robust. There we go. Now the transformer primary. Beautiful. right. Let's make that permanent. Great. Okay. Let's do the hot. Tin it a little bit. Great. Let's just like butter. And then we'll take that directly to the fuse tip with the wire that's already on the fuse tip. So we're gonna recycle as much of this original wire as we can here, and probably only need one extra piece for the negative feedback switch circuit. Let's get some mechanical connection on that. There we go. Alright, those are on there pretty good. Solder them in. Solid. Tuck that up out of the way as well. See if we can go up and over with this. Yeah, that's probably our best bet. This terminal ends up not being used, so that's going to be just fine. Hot to the fuse. And now we need to recycle one of these little pieces of wire to go fuse to the switch. So let's clean up the terminals first because they're a mess. There, now we can see what we're doing. Same over here on this non-standard switch. Again, this switch is not factory, obviously, because it goes down instead of up. That's got it. Okay. Recycling original wire. To go from fuse holder to power switch. connection. Solder that in. AC is tucked up along the top like that. Out of the way. Transformers, primaries coming down here. Twisted where we can. Heater windings back up and out of the way. And I think we can put our strain relief back in. These are always fun. Okay, that's theoretically correct. Special tool. Yeah, we're in. Great. Okay. AC portion complete. And while we're here, let's do this negative feedback switch. I'll clean up. Oh, we already cleaned those up. This one could take a little more cleaning. There we go. I'm gonna check the shot here to see if you're gonna be able to see what I'm doing. Turn it a little bit. Sorry about that. Yeah. So your negative feedback resistor is right in between here, 820 ohm, and then it goes under the board, and that's this yellow wire connects to it. It goes in and around and over to the output tap of the output transformer, that is your speaker jack. So we remove it from here. Probably a little solder. Get it flowing. Yep. One more hit. And then we bring this in and around the back to the newly freed up switch. Just got to get it on the other side of these output transformer secondaries, or it won't reach the switch. They were pretty nice and tight with their wiring back then. Okay, should reach now. We'll go in and around and behind. The 6v6s. And even the power switch if we can. Yep. Perfect, so we're using original wire again. A secure mechanical connection here. Beautiful. Solder it in. So now, instead of negative feedback resistor getting tapped off of this output transformer, it's going to the switch. So now we need to get the other end of the switch over to the output transformer. And that will mean a new piece of wire, because the two that we decommissioned out of the power set situation are too short. So I've got some nice period correct cloth covered yellow wire, just like the stuff that's in here. A little brighter yellow, but pretty good match. And again, this is a very undoable mod, because you just take this wire out and put this wire back, and then you're good. And when the switch is off, you're back to stock anyways. The resistor's in circuit, so it's very unintrusive mod. Again, we're going to go along in behind the back, and we don't want this any longer than we need. That should be enough. Should be 20. Yep. Nice insulation. This really is just like the stuff that's in the amp. So we'll get both ends trimmed up. Come on, fluff. Get out of here. There we go. Defluff. Couple stray strands of yellow too. And the rest will probably just burn off with the iron eventually. Okay, so it's actually the bottom terminal that we need, so we gotta clean that up a little. Make some room here. Beautiful. Give that a little wrap. Nice. And then, yeah, up and in behind. All the way over to the output, which is where the negative feedback is tapped from. So again, this switch will either be, tin this first, will either be normal negative feedback or no negative feedback. There's no in between with this particular way of doing the mod. Some of the later Fenders had a 3-position ground switch instead of just 2, where you could have a third option of like half negative feedback or something. But we don't have that here, and we don't need it. Yep, we're in. And wrap it for security. Solder that in place and then trim those hairs just a little bit more. So we got trem to be up there. Got it. Beautiful. A little haircut. Okay. Nice and snug. Okay, so that is the rewiring of the power AC section to be up to code with the long ground and the fused hot going to the switch and the neutral going to the other primary on the power transformer. And we did the negative feedback mod. We added the switch in series with the negative feedback resistor. All right, that's it for now. Okay, so we got a little intermittent chunk on channel 1. I've swapped tubes, so it's not the tube itself. I'm actually wondering if it's the pot, like, not making great ground. See that? Hear that? So I'm gonna pull that pot off and clean and tighten. See if we can make that go away. Like it's not the soft shorting jack here either. I tried making good contact there, and it doesn't change it. So if I touch these, yeah, something's up with this pot's ground, so I will figure it out. We'll get to the bottom of it. All right, so I cleaned and tightened this pot, and we get no more hum and buzz. So I think it just wasn't making a good clean ground. There it is again. What is it? us. These are not sounds we want. I mean, that could just be a microphone too. That is not V2. So let's pull V2. Take it off standby. Still chirping. Let's pull V1. Take it off standby. Nothing. So it's something in the signal path of the first one. So we'll swap tubes back so we have the tube that used to be V1 back in V1. Still there. So it's not the tube itself. Something between, let's see. Yeah, so it's not from the pot. It's not after the pot. So it's between the input and the first stage of this 12AX7, and that's way back to the volume pot, which is an attenuator, really. So that's not a very big chunk of circuit, so let's find it. Okay, got it. So it was actually input 1's input jack not making a great short, so I cleaned it again, very subtly retensioned it. You see what when I pull it off manually from the shunting strip there, that noise comes back. That's what we were hearing, and now I can bang away. No action. Volume's up. So what sounded like a microphonic tube was just actually physical vibrations making this little contact here insecure. And it's very clean and very secure now. It takes a lot of effort to bring the buzz. Solved, but not entirely solved. So it's also number 2's jack. See the noise floor right now? Like these jacks are sort of wired differently on purpose. Input jack 1 is a higher gain because it turns these 68Ks into just because they're in parallel, just a 34K or whatever half of 68 is. Whereas on jack 2, it treats them as a voltage divider, so it's 6 dB quieter in jack 2. If jack 2 is actually properly shunting, then jack 1 operates in its normal way. But if it's not, you get more noise. So check this out, noise floor, and then when I properly force this shunt to be a good connection, the noise floor drops. Hopefully that's coming across. So I need to get in there and retension this one. Just cleaning alone isn't going to do it. It's just a little floppy. And in its unaffected state, it's actually not shunting. So it needs to be manually pressed closed to shunt. So we'll have to retension that one. See now over on input on the vibrato channel, these ones are working good. I have to physically move it off, and then I get that extra hiss that I'm getting on channel 1 without doing it. So these ones are good on the vibrato channel. It's just now down to input 2 on the normal channel. Okay, so we're gonna do a little de-ticking of the tremolo roach. And if we have a listen to the amp as is, tick, tick, tick. And then we're gonna clip in this 10 microfarad cap, put it on standby while I connect these leads to a live amplifier. Don't try this at home. And then take it out of standby. Million times better. Nice. And again without. So I think we'll solder that in. I was going to solder in the D-tick cap, and I noticed that, I mean, maybe this is I think this is a replaced roach. And it was just tack soldered on the top of this eyelet. It wasn't even through. Just tack soldered on. So we'll fix that when we add our new cap. But yeah, I don't think that's factory. Anyway, it's strong. Success. No tickety tickety. Okay, so a couple things have been done here. I can show you. Trem has been de-ticked. Alright. But yeah, I'll show you how, you know, as you turn the trem intensity up, it seems to get darker and quieter overall. So here's pretty low. So deep, but I also think it's sucking some level out and some low end out. Anyway, I was doing that before the D-tick, but the D-tick is in there and working great. Sorry, that hum is just my guitar because I'm close to the power transformer here with my pickups. So that's working great. We'll investigate the trem a bit, but yeah, I don't know exactly what's going on there. And then the negative feedback switch is functional. So let's see, we're at like, you know, 4.5. I'll just play some shit and switch it over for you and you can see the difference. Noticeable in the mids, because that's sort of what the negative feedback scoops out, and without it you get a little more mid push, a little more forward and dirty. Hopefully it comes through on the iPhone mic there. So yeah, that's working great. Trem's de-ticked, input jacks are solved. this guy's holding for now. I might check in on him before I seal it all back up. But yeah, that's going great. So we'll just recap the power supply and retension the tube sockets because they basically want to fall out, especially the rectifier. And if you want, I can put in some bear traps like on the bigger amps, like on the Vibrolux and stuff. It just has those little metal clamps that hold the tube in place as well. So I figure for a gigging amp, it's probably good to have. They just cheaped out on the Deluxes because they wanted to save a few bucks. So yeah, we'll just keep going at it and see what else we find, but so far so good. Oh yeah, I wanted to show you too, I rebiased. So we're at 19 milliamps current per tube now instead of like 9. And we're outputting about 8 watts, which is, you know, 65% of the max dissipation for a 6v6 instead of like 38% before when we were at 4 watts. So I think that's going to make a huge difference for you too. It'll just be more robust and lively, and nowhere near being at the point where we're biased hot enough that you have to worry about tube life or anything. It's still, you know, in the sweet spot, almost slightly conservative, but not really. Okay, this one's pretty subtle, but might be worth doing. Not very pronounced on your amp, but the bias circuit does introduce a tiniest bit of hum, and you can kind of hear it if everything else is real quiet like it is now. Hopefully that's picking up on the camera. It's that low 120 hertz hum. Boom, check it out. And then if I clip in this cap across the bias pot from wiper to ground, we'll listen for the differences. So here we are listening for boom. Probably need headphones. Boom. Here it comes. And without. Pretty fucking subtle on this amp, man. It's real though. Another tiny little bit of tube noise. I'm hoping that all goes away when I clean these sockets. But it's possible that your tube that's in V1 here is a bit in poor health. But we'll see. Anyway, so here that is one last time. Try that again from the front so you can really hear the low end. So right in front of the speaker without the cap across the bias pot. And then I'll put it on. Here it comes. Taking it off. Also, hey Marcus, I'm gonna throw in a new power switch that's oriented in the right direction so that up is up, down is off. I mean, up is on, down is off. It's just it's a little bit dangerous, actually. I mean, maybe you're so used to it now, but every other amp in the world's the other way, and like, it's even my mind fuck to work on because I'm just so used to, okay, that's off, zap. You know, nothing bad happened, but it could. And just, you know, if someone else is using your amp and they don't use the standby switch the right way or something, so if it's all right with you, I will swap it out for a nice one. I'll probably take off the little on off sign, so it's just gonna look exactly like the old Fender one did. This has been replaced too, your standby, and it's upside down as well, but it can be rotated physically without worrying about the leads touching the chassis. So I'll rotate it and put in a new power switch. $20 for the switch. It's like a Carling super robust 6 amp switch for mains switching like that, but I think it's worth it. So yeah, let me know.